Okay, Jennifer, who else wants to join? How to unlock the whole stuff? Martin? E. Anyone know how to unlock everyone at once? Share screen, Koji. Okay, it's open. You should be able to join without permission. Okay.
Okay, so here's an overview of the talk. We'll be in a minute. Slideshow. Okay, so here's an overview of the things I'll talk about tonight. First, we'll talk about the Agile Analytics group here at Thoughtworks. We'll talk a little bit more after that about the field of data science in general, kind of where I think it came from and where it's going and where it is right now. We can debate too whether or not it's good or evil, that sort of thing. I'll talk a little bit about the technologies, more so the limits of technologies. I think that there's too much focus on the technologies and big data and that sort of thing. I think for consulting, we found that the biggest challenge is the process of dealing with working with the business. It's not the same as working with a bunch of PhDs in physics. Surprise, surprise, right? So I'll talk about kind of what we learned there. So Thoughtworks, first of all, you are here at Thoughtworks, so you know a little bit about it already. We're a global software company. We have headquarters in Chicago. We have big offices here in New York, San Francisco, Dallas, and lots of other countries: India, Brazil, Australia, China. We're privately owned by Roy Singham. Roy's an interesting guy. He's a CEO and a socialist, so that's kind of a rare combination right there. It's a different kind of consulting company. It's a very flat hierarchy. We're all it's kind of like being a postdoc or something. Like nobody's really in charge. You all argue against each other. But it's great in a lot of ways, and it's a fun place to work at. We talk about the three pillars here at Thoughtworks. The first pillar is not going out of business. That's very important, especially for the other two. So the other thing is kind of championing the field of software development, kind of being stewards, making sure it's going in the right direction, or at least doing our part. We use a lot of, we contribute to the open source community. We try to keep the data pretty open. We're against things like spying on our citizens and that sort of thing. The third thing that's really different here about Thoughtworks is we really care about doing good for the world. We spend a lot of our time doing these things. Thoughtworks will do a lot of projects that don't make any money for them, just to advance society. So the Agile Analytics group here at Thoughtworks, this was started in 2011 by Ken Collier, who was brought in, John Spence, who's in the back there. They started the group. They hired me as a data scientist about 2 years ago, and now we have about a dozen people involved. It's growing pretty quickly, which is nice. So this here is Ken's book. You see up top. We're also handing these out, I guess, or maybe they're prizes or something. But, so the main theme of Ken's book was that the field of BI, at least in data warehousing, had progressed very little, and they hadn't really benefited at all from the transformations in software development. The agile methodologies that have worked so well in software development never really came into BI at all. So it's been kind of waterfall, very kind of big bang projects. A lot of them have failed. So we're trying to, Ken's main thesis in this book is really to try to bring in the things that work in software into the field of BI, which we now call data science. There's some other books here by people who work at Thoughtworks, Refactoring Databases by Pramod Sattelaj. And Martin Fowler's book, and promote as well, called NoSQL Distilled. So what do we do here? The data scientists here, we do anything. We do a lot of Bayesian modeling. We do anything predictive machine learning type stuff. We do some of the stuff we do is prescriptive. So we're consultants. We're not management consultants, but we still do a lot of trying to find trends, trying to tell the managers what's going on in their company, helping them to make good decisions. We're involved in big data technologies, of course, because the data sets out there can be quite huge. And myself, I work a lot on the algorithms. I tend to think that speeding things up is more about the algorithms, less about throwing 100 nodes at the problem, right? So there's a lot of great things being done these days in data structures, scheming algorithms, that sort of thing. Pretty cutting edge, and they're fun to bring in and kind of work on real problems with them. So our two main goals really is, when we're working with a business, trying to give the company some kind of edge, right? So it's kind of like when we were traders, we do that kind of thing too, right? But it's that's the main thing that I really want to do when I come in to work with the client. I want to figure out how the business works and try to make sure we're working on the most important thing, right? Be there in the work on the important things, not just set up the database. Right? So, and then of course, when we're not working at a company or working with some other group, try to use data analysis to improve the world at large, help society, that sort of thing. So the typical projects we work on, we see a lot of recommendation systems. You've probably seen these, heard about these. They use Netflix, for example, to recommend movies. These things are, they can be fun to work on. A lot of the techniques we're using are fairly cutting edge. They cannot last, 5 or 6 years. Some of the classic algorithms, like the collaborative filtering, still work pretty well on a lot of problems. Some problems benefit from things like matrix factorization, which are a little bit more advanced. And then there are new algorithms coming out, like probabilistic models, that are pretty neat for this sort of thing. We haven't used them yet, but they're doing better than the other methods, so they're fun to look at. Customer behavior analysis, this is a huge area. Find out what the customers are doing and why the customers are leaving, for example, or trying to find the customers that are the most important to the company in some way. There's a whole field of optimization. It's basically just the decisions that are being made at companies are often kind of made with rules of thumb. And a lot of these rules of thumb are pretty good rules of thumb that they've developed over the last 30 years. But they're not the optimal solution, right? So a lot of the things we can do is really try to optimize those parameters of their business. The efficient algorithms, I talked about those already. For massive data sets, it's you really benefit from figuring out some way of kind of choosing a data structure that's made for the problem at hand, right? You can use, say, like a tree data structure. Sometimes you can get speed ups of thousands and that sort of thing. So we find a lot of those kind of opportunities. And then there's company-specific things, which I find the most fascinating. When you work with a company, you often see problems that you've never seen before. They have no category. They don't have a name. They're just weird problems that you can try to solve with probability mathematics and that sort of thing. Those are great, and that's partly why I like being a consultant, that you see all these strange problems. So I'll talk about one case study we did. So this is with a healthcare GPO. So what they do is they're basically a group that the hospitals join. The hospitals pay a fee to join, and they get to buy things at a better rate, right? They group together. They have more power with the pharma companies and the other companies who make healthcare products. So the GPO has to, when they want to get a new customer, they have to go to them and say, if you join us, you'll probably save 10 to 12% or something like that on your purchase, right? But in order to do that, they need to actually do some calculations, right? And the trouble is the GPO they have thousands of healthcare products, or tens of thousands, and they have their own catalog about what they're called and something. And the hospitals are not, so they'll have all the data in spreadsheets, for example, and they'll have the description of something in some strange way, and they have to match up these things. So it's really it's a messy matching problem. It's a lot harder than regular retail because we have SKUs, SKUs in retail. Healthcare, not so much. There's not a lot of standardization yet. So for example, the GPO will have something listed as Johnson & Johnson's sterile scalpel number 58505. They'll have something like that, and the hospital will have something like that, but it'll be different, right? It'll be like the second line here. It'll have the ID in there, but the dashes are gone, the capitals are gone, or the description is slightly different. So the trick then was kind of matching these things up, and the solution they had was it was a pretty big heavy solution. It used a lot of Oracle, like an array of ETL tools. It was doing a lot of the calculations right there in SQL, right? And it's taking forever. It took them about a day to run all of these queries. So we looked at that, and they weren't even matching that well, and they matched like 60% rates. And the trouble there was when they weren't matching with the algorithm, they had to do it by hand. So they had a group of temp workers who come in, 10 of them, spend 3 weeks going through and finding all the lines that kind of matched up, and so it was a lot of work for them and a lot of wasted money, right? So what we did, the first thing was to convince them, which we would recognize right away, like it's not that much data. The calculation should be able to be done in a few minutes, right? And it was hard to convince them of that because they've been working on this for years and it was taking them a day. And so the solution was really just to do things in memory, choose a data structure for which the searching could be done quickly. So when I was in there, we wrote some Python programs, for example, using some like a tree data structure and some machine learning to kind of combine the answers in the end. And it ran on our laptop in a few minutes, and the match rates were higher. And it was done in about 3 weeks. So it was great because we can come in and say, here's a prototype, right? This is a prototype on my laptop it could run. And but we could do the same process that they're doing. We could do it better. And so the next stage was kind of moving this into a different phase. Oops. Yeah. So we used some technologies for the prototype, just in Python. Then we moved on to somewhat heavier duty things like Elasticsearch, and worked out pretty well. Another case study here in the.
Dave,
Yeah.
question?
Yeah.
So you said the match rate is clearer than 80%.
Yeah.
How many records are we looking
How many what?
at? Record size.
Tens of thousands. Well, it depends. So for a given hospital, they might have 10,000 records, right? The GPO itself would have maybe 100,000. And they had thousands of customers, right?
And then your result, do you need human, sit there for validate?
Yeah.
Correct?
Right. So the first thing we did was something like that. We had a list of just 500 lines, went through them by hand very carefully, and they classified them, and we were a little surprised when we were getting the better rates on the first attempt. It was great. But yes, measuring that rate is a hard thing to do, right? It's for a different customer, the results will be different, and you don't want to send your humans through and classify millions of lines, right? So they did enough to be pretty confident that the rates were higher.
I mean, you could always do this once and then flip it around saying, all right, for this scalpel 505, this is the one that you have to pick. And then send it out to your 1,000 hospitals, and then when they go to order, they're hitting a pick list with your list, not you, not trying to consume all of their lists.
Yeah, yes.
The other direction.
Well, the reason that doesn't really work is they have, because their list is like all products. Right? They have a contract on almost every product in healthcare, right? And there's a lot of complications over the combinations of products, because you'll buy a contract, you don't buy a single product. You buy a contract, so you'll buy J&J's scalpels, for example, and then you have to buy all their things. So it's complicated. Doing the optimization is tricky. There's a lot of constraints there. The other thing we have to do is try to match up the contracts to the products. Once you have the product, which scalpel it is, there's different contracts for that. Right? So it could be J&J, but there could still be 5 contracts with J&J, depending on the size of the hospital and their market share and all kinds of things. Healthcare is extremely complicated, and it's amazing to see how this stuff works. It's just there's layer upon layer of complication in this market. So, okay, so another project we did recently was this is a recommendation system for a. What they do is they provide coupons and recommendations for coupons to retailers. They have a record of pretty much all their purchases from the customers from all their retail clients, right? So they have tons of data, hundreds of terabytes anyway. So they want to make recommendations for coupons based on what you bought in the past. And when we came in, they were doing something which was fairly good. It was this red line actually was their most current model. The black line is what they were doing a couple of years ago. The pink line down there on the bottom is just random. You just randomly pick one. And surprisingly, it doesn't work that well, right? So the blue line we were able to deliver. This is sort of a Bayesian model. When I worked on this, I kind of wrote it from scratch as a Bayesian model, and then I think it's probably related to some of the cloud filtering models. But it's a little custom because their data was a little bit different than, like, for example, you run into this problem where they'll have a hierarchy, right? So they have all their products, they'll have a SKU for it, and then they'll have a category. Like for example, it'll be say you have like Coca-Cola 12-pack of Coke, right? And then the SKU will actually change because it could be the pack of Coke that has a picture of the Olympics on it, for example, right? So there's different SKUs that are really the same thing. It's Coke, right? And it's a 12-pack of Coke, but it's they have a different picture on it, different SKU. So it's kind of complicated. So if you run up the hierarchy, there's you can go up to Coke, and then you go up to sodas, and then you go up to junk food sodas. But so trying to work within that hierarchy was kind of a difference from a normal recognition system that we had to deal with. So in the end, we were able to deliver a pretty competitive model, and that was fun work we did. So now I'll kind of talk a little bit more on what is data science, and there's a lot of questions which kind of go along with this theme, like, is this really new? Is this really, if we call it science, does that make any sense at all? Probably not, right? Whether or not it's a fad, there's a lot of hype, and why it became popular like 5 years ago, right? And where is this going? And then I'll kind of recommend, should people go into this? Is it a fun thing to do? So the answers are, is it really new? Not really. Does the term data science make sense? I'd say not really, but so what, right? It's a title for a field, it's a job title. They don't really matter that much. I think it sounds kind of cool. So, is it a fad? Is it hyped? It's definitely not a fad. Is it overhyped? Perhaps, but things that are popular always get overhyped. So a quote from the man who works at Thoughtwork said that math is not a fad, right? It's like a lot of the stuff we do is just mathematics, connecting things with math and statistics, and that's definitely not a fad. The question is whether or not it's worth the while the company to hire you to do this, right? So my big thesis on why it became popular a few years back has to do with productivity. It's, I think, a pretty simple explanation. It's not that something magical happened 5 years ago. Where is this going? That's a long story. Should scientists do this? I would say yes for most. If you're a scientist, like a postdoc, for example, first of all, there aren't that many jobs in academia, so you have to do something. I think this is one of the most fun things you can do these days. I think it's valuable. The reason why I went into this field, not into trading, is I just thought it was, you're creating value in the world. Trading is a lot of zero-sum games, and it's not exactly zero-sum, but I like the idea that I'm not just kind of placing a bet on the companies that actually help them solve their problems. So, is it new? Well, of course it's not new. The math and stats and all the theory that goes behind it, and the computer science, that's not new stuff. It's been around a long time, right? So it's a combination of many different fields: math, stats, computer science. Operations research is a term some people don't know very well. It's kind of like data science, but it's on the side. It's a term not used very much, but there's some programs where they really kind of work on the optimization of businesses and processes. And I think it needs to kind of merge in more with the rest of our field. I think it would be useful. Business consulting, if you're working for a business, either as a consultant or actually just working for the business, you have to learn a lot about the business, and you don't learn that in the academic world, right? Software development, we're writing a lot of software, and we write software a lot differently these days than we did in the 1990s, so a lot to learn there. And this has been going on in the business world a long time. Since this, in finance, in the insurance industry, you're making bets all the time. It's all probability. Sports, the government, Google's almost 20 years old, so it's not really that new, right? And of course, it's been going on in science. We've been doing this in astronomy, and physics, and biology with the Human Genome Project, etc. So is there anything new? Yes, of course there is, right? So I think the main thing new is not really the technologies, not really the methods, but more so that we're becoming more of a community, right? And it's finally becoming popular in the business world. I think it should have become popular a long time ago, but there's always little lags in these things. And the communication between all the different fields is great, and I think that's something we were lacking a few years back. And it's finally work that's fun to do. So if you're going to pull people out of the jobs in academia or trading too, or whatever, it's got to be a fun job or pay a lot of money or both or somewhere in between, right? So it's a big movement. It's real. Let's give it a name. Call it data science. So why now? This is another question. Why did 5 years ago this become popular? So I think you have to realize, the job prospects in academia are slim. That's why I showed you this first plot. A bunch of postdocs, and there's a new trend. They jump into it, and then it works for a few years, and then they go into some other field. But I think the longer term trend is the productivity has been going up for a long time. So if you made a chart, for example, this red line is the productivity of data scientists, right? So I think it's been going up quite rapidly. And the blue curve on the bottom is the salary for a postdoc, and the green one is 2.5 times that, which is the level required to get somebody out of those jobs and move them into something else. And I think it's just the case that a few years back we kind of crossed the threshold, but the productivity was high enough that it made sense for a business to actually hire you to do that. Now, the stuff that we're doing now is not too different than the stuff we were doing 10 years ago or 20 years ago, but I think our productivity is about 3 times higher, which is why maybe our salaries are 3 times higher, right? So, I don't think anything magical happened in 2005, 5 years ago, or anything like that. I think we just kind of crossed this threshold, and once you cross the threshold and a new thing gets going, there's some feedback effects as well, right? Yeah.
Are you going to get to why the productivity is so much higher? You
Yeah.
mentioned different engineering processes. But
Yeah. Next.
You shouldn't times 2.5 for postdoc salary.
What?
The postdoc salary.
Yeah.
5 times.
Maybe I need a new job. I don't know. Yeah.
The data scientists are more general purpose data scientists, and financial data scientists are quants. So in the 1990s and until 2008, most of the data scientists were quants.
Yeah.
Now, from 2008 to the present, we call it data scientists because you're applying the same techniques into the general purpose for all
Yeah, I
industries.
think so. It's probably due to just the busting in the finance bubble, right?
You're getting all the quants that were working in the investment banking firms and hedge funds applying the same techniques into all industries.
Yeah. Yeah. I
That's why
think
you
the
get
2 main
data
sources right
scientists.
now.
But if
okay.
you separate it, you say quants are
Yeah.
financial analysts, financial quants for finance and finance alone. Data scientists should be for general purpose, and that's the people that confuse it. Because data scientists are for other businesses besides finance.
Sure. But the reason why they're there in the first place is either there aren't enough jobs in finance anymore,
Of course.
or
Because if you're changing the top 5 banks, they're not innovating enough. They're not because of regulation, and you're getting excess people that you can move into all industry and transition them to.
But it's not just the amount of jobs and the money they'll pay too. It's a really different kind of job. I think a lot of people got fed up with finance. They they were a postdoc, they're doing science. They went all the way to the other extreme and did finance for a few years, and now they're coming back, sometimes by choice. So yeah, the productivity drivers I kind of listed along. I have separated these into kind of the long time scale and the more recent. The long time scale, of course, computers, Moore's law, and everything, and that's been pretty constant now for 30 years or so. The internet, which is kind of obvious, but like back in the 80s, we didn't have the internet at all. In the 90s, we had the internet, but it's been getting better and better in a lot of ways. Like Wikipedia, for example, is just fantastic now for learning math. You can go online and learn math. You can buy math books. So that's particularly that's more important in poorer countries where they can't afford the education or anything. But you can pretty much just learn everything on Wikipedia these days. I don't think you have to go to college anymore. Learn math. I think hard drives and RAM, the price drops on those, so we can store a terabyte in our laptops these days. It's great. Science kind of learned to deal with big data first, I think. The astronomy experiments I was on in the late 90s, we had 40 terabytes of data, which was huge then. So just kind of learning to, when you have that much data, first of all, you have like one shot to go through the data, right? It's the same in particle physics, as I'll talk about in a minute. You have to make a decision which data to keep, which to throw away, and really focus on the information. The growing importance of statistics. So again, when I was in grad school, scientists knew the basic stats, right? They knew things like p-values and that kind of thing. But when we got more and more data, and the data became more and more complicated, we had to learn real stats, Bayesian modeling and that sort of thing. So Bayes is, I don't know, 100 years old or something like that. But we really started doing a lot of that in the 90s. I don't know why, but I guess we didn't have much data before that. And we didn't have the compute power as well. Right? So a lot of the techniques of Bayesian modeling, you're running Monte Carlos or doing complicated calculations, and you just can't do them on paper. It doesn't work that way. So, was there a question? Yeah.
So big data, what is your view on big data?
I'll get to that in just a bit. Okay, and then the more recent stuff, I call it Git, but it's more general. All the code sharing that goes on, that just didn't happen before. The way it used to be was you get a book and you write everything from scratch, and everybody would keep doing that and reinvent the wheel. And, there's so many libraries available today that you don't have to write those low-level things. The matrix calculations. There's just libraries for those things. You would never write how to do like LU decomposition. You wouldn't write that anymore because just to be wasting your time. I'll give a little call out to Hadoop here. Hadoop and the ecosystem around that are important. I think they get too much. I think people put too much emphasis on those and think they kind of cause the boom in data science. I don't think that's true at all. But I do think they're very useful. They're very great for certain problems. The cloud is very important. Again, back in grad school, you didn't have the computing you needed to do big calculations. If you did, you'd go buy a server, and the expensive server would sit there for 6 months while you figured out your model, and then you'd run it on it for a couple of days. So it wasn't a very efficient way of working, right? So again, the productivity that we can just use our laptops, and then when we have a huge calculation to do, we can spin up 40 nodes and do it. It's fantastic. It's a big benefit. And then there's the technology. The NoSQL databases are great. They have their purposes. So the amount of memory you can get on the cloud, I think you can get service for like 200 gigs of memory, almost 300 gigs. So the in-memory stuff that you'll be able to do in a few years, when that gets to be terabyte of RAM, it's just it'll be hundreds of times faster than the stuff we do with disk today. So that's driving a lot of it as well. And then I think just when you have a community which kind of forms together, you get the cohesion, the kind of cross-learning between the different groups, and then the kind of feedback affects the popularity. By that I mean, when it gets popular, finance will fund it. There's more startups. They create good products, and it kind of feeds on itself for a while until the next crash, right? Then and now, back in the 90s, you'd write code in C, not very well either, and it'd be buggy and slow. The data you'd use like MATLAB and IDL that we use is, it's not only that you have to spend the money for the license, it means there's 100 little communities using different softwares. And these days, we're using things like Python and R. Those two languages, I think, probably account for, the majority of the work we do, right? Probably more like 90% of the work we do. So there's, great communities behind both of those, and we're better at SQL than we are now, and we have a lot of other options. With Git, it's all the libraries we can just get. So, so all these things help our productivity. It makes us so that we can concentrate more on what we're good at, the math, the modeling, and that sort of thing. Okay, so here it is, the definition of data science. An interdisciplinary field utilizing statistics, computer science, and the methods of scientific research in areas outside of science. That's my definition. So it meets all these requirements of science. This is the dictionary, the definition of science in the dictionary, except for number 1 there, right? So it's not a study of nature. We're not studying the natural laws. But it is the rest of these work. It's a what's my favorite one there? Any particular branch of this knowledge. Okay, fine. It's basically a study. It's a science in the old-fashioned terminology, right? In the same sense that like boxing is the sweet science, right? It's not really science either. So where is this all going? I think some of the big trends we'll see coming up. I think the big data technology is going to be separated from the data science field. I have always thought that they're not really the same thing at all. And the big data stuff is, I think, the roles of kind of working on those things will be taken over by the developers at companies. Because I think they're really developer tasks. And the data science is more like mathematics and modeling. And the data is not always big. So I think they're quite different things. And I'm a little surprised they've been kind of lumped together. The businesses will begin to understand the terminology we use in data science. This is a big problem that we see. You go into a company and you want to build a model for them or build some kind of product, and you spend the first 2 weeks just kind of going over the terminology and telling them what the precision is and the recall and cross-validation, how this thing works. So you spend a lot of time doing that, and again, in a couple of years they'll be used to it, right? In the same sense that when software developers are working in a company, they know the language, they know the lingo, so they know, I have to refactor my code today. It's going to take half an hour. They know what that means. You don't have to spend another half an hour telling them what refactoring means. So I think in a couple of years, again, this will be much more fluid. I think the businesses will understand that they're not Twitter and Facebook, and just because those tools being used by those big companies are popular, they don't necessarily need them. Where else is this going? Specialization. I think the most experienced data scientists will move into a consulting role or a management role. There's a lot of stuff we do that's lots of other people could do. We're not going to produce 100 times as many data scientists as we have now. We'll kind of break those into different roles. And there's a lot of programs now coming out in universities, which called a data science light. It's not a good term, but we don't have a good term for that. But you're just not going to learn in 4 years how to do a lot of the things, but you'll learn to do a lot. Fewer generalists. So the thing we try to do at Thoughtworks is the developers can learn a lot of these skills. They can certainly program a lot better than we can, so they should be doing a lot of those roles. It's just kind of figuring out how to get to work together more efficiently. So PhD students need to learn additional skills. So again, when we're hiring at Thoughtworks, we see a lot of people who come out of academia will have their PhD, and they think that's all they need, right? But there's actually a lot of things you need to learn to be a data scientist. And the technologies that are big in data science are not really that big in science. No one uses Java in science. JVM, I don't know what that means, right? Scala, yeah. And Hadoop was, at least a few years ago in science, it wasn't very popular. So all those skills, they take a while to learn. So it's not just knowing math, right? So why won't we have 100 times more data scientists in years? The disgruntled postdocs, there's only so many of them, right? You can only get so many people. Or you can call that, I'm not even supposed to be here. By that I just mean that, like, if 20 years ago I learned I was going to be a data scientist, I wouldn't have gone to grad school for 6 years, did 10 years research as a postdoc and that kind of thing. So I feel like a lot of the data scientists are not really, they're here, by accident, right? It's not a natural route, and we're not going to get 100 times more of those. So, and the other thing is, the experience of working with data is just really hard to learn in school, right? I mean, school is about learning the mathematics, the formulas and the methods, but actually working with data, and it takes a long time to kind of pick up those skills and learn all the tricks. So are we there yet? The hype cycle, whatever. I think we're probably not there yet. I think partly because the productivity growth has been real. I think it'll continue to be real for the next several years. Because I know just the work that we do at Thoughtworks has been getting better over the last couple of years, and we're learning a lot more and getting better at it. When we go into companies, we're solving good problems, and we see plenty of other problems. And I could easily see, 5 times as many teams working for them solving those kind of problems. So I think there's a lot of work left. I think big data may peak before the rest of data science. I think it's already kind of peaked in some sense that no one likes the word big data. No one really has. But I think the field is starting to get it that they're not all Twitter, right? They don't have petabytes of data. It's not all about the size of the data. It's about the the complexity of the modeling. So last night I watched was it the Masters last night? I don't know if anyone saw it, but right at the end there was a commercial from IBM. It was like the first commercial on the data science I've seen in my life. So it's it's the first one, right? So I think we have a lot of room left. Big data, it's when it peak, right? It's the first thing I'll define is big data. Somebody asks, what is big data? And you can give a lot of definitions. I think some of the important things is it's too big to do it on a laptop, much too big, right? You wouldn't even think about doing it on a laptop. And a lot of the data we see at companies is really not that much bigger than what you can handle on a laptop. Sampling helps a lot when you're building models, but it doesn't solve every problem. Sometimes you can't just sample the data. You have to do a calculation for every customer and sort of thing. We try to focus on data reduction, and again, sometimes it's not possible. Sometimes you've reduced the data as far as it goes. And if it's still in the terabyte range, then it's big data, right? Or the multiple terabytes. Storage and compute being closely balanced is important, right? Most of the time, the CPU is sitting idle, not being used, and it's all just the I/O as the disk churning away, right? So if you're going to go to something like Hadoop and you have 20 nodes, you want to be using all those nodes, right? So if you have a compute problem that's fairly complicated, it's a lot better than just the kind of problems where it's the I/O, right? And usually, a better algorithm is the first place to look, not just throwing a lot of nodes at the problem. So Hadoop, and this also applies to Spark somewhat. Spark is kind of the newer version of Hadoop, much faster, like 100 times faster, they say, or 10 times faster, depending if it's in disk or memory. So, Hadoop, I think, there's certainly the good cases and there's the bad use cases. The good use cases, these large batch jobs, you have a terabyte of log files, and you run it on that and gather up the information on the logs. That's the perfect job for Hadoop, right? When you have to score the machine learning, so I think when you're learning machine learning, you can often make do with a very small sample, right? If you have millions of data points, you may only need 1,000 data points to learn that model. If you have billions, you still might only need 1,000, right? So, but when you're scoring, sometimes you have no choice, right? If you have to score every single customer, you have to run it out in a big batch process. That's a good use case for it. And then when you're storing data in HDFS, it's a great thing for that, right? The bad use cases, again, the model development, especially in the early phase where you're fiddling with it a lot, trying different models. It's much better to work in Python or something like that where you can get feedback very quickly. You can use the visualization to have a look at the data. A lot of things we see is just kind of using it for brute force, right? So the calculation they're doing takes 3 days. So they say, oh, we'll get 30 times nodes and run it on that. But again, I try to focus on the algorithm, not the just throwing nodes at it. And then treating Hadoop like a database. It's not a database. There's a lot of other options for that. So what are the data sizes you typically see, right? And this is most companies have a few million customers. Maybe they have 10 million, 100 million, but it's of order 10 to the 7. And the things they'll store for each customer typically around 1,000, right? If those things are like purchases or something like that, or like the number of times you've logged into their site, or the things that the customers write, they can only write so fast. So you can't get really big data that way, unless you have maybe 300 million customers and it's Facebook or something like that, right? So typically, you're coming out around 10 to the 10 data points, 5 bytes per data points. That's half a terabyte, right? Or a few terabytes. So that's the typical thing we see. It's not the complete set of data that a company has, but the main set of data that you deal with. It can fit on your laptop. It's about that point where it's it's hard to do, but it's not impossible. And you can move it to the cloud in maybe a couple days, right? It's not going to take 6 years to move to the cloud. This is true when the things like purchases or those sort of things. It's not true when the things like web events or the other ways you can get really big data is from if you have to do some kind of pairwise thing, right? If you have like a social network or you know, if you have 1 million customers and you have to square it, obviously it gets enormous. But we typically don't see that. The other big kind of source of really big data coming down the pipe is any kind of sensor data, pictures, videos, health monitoring devices, and things resulting from this kind of combinatorial complexity. Now, while this is true, and everyone's kind of talking about this coming down the pipe in a few years, you have to ask the question: is it really, you know, is it really something of value to the companies? You know, yes, you can produce a lot of data with a camera or video, but is it really going to be worth it for them, profitable? A lot of the times the answer is no. Streaming algorithms, again, this is when you catch the data on the way in and you do the processing in real time and you don't actually store the raw data, right? So again, this is becoming really big. Then I think we just need to learn to focus more on the information, not the noise. And the best case study for that is in particle physics. So this is the LHC, the Large Hadron Collider at CERN in Geneva. They have 600 million collisions per second. Well, that's a lot of data, right? And most of these things are boring events. They're not what they're looking for. They're looking for the Higgs boson, which has this pattern here, you see. But they still save a lot of data. It's about 100 petabytes per year. It gets up there. But the goal is to find the Higgs boson, right? So that's to determine whether or not the Higgs boson is really there. So that's one bit. It's a Boolean, right? You see the true or false. So that's one bit. And the other thing, they measure its mass to 1%, which is about a byte of data, right? So they, at the end of the day, they only need to measure 9 bits, right? And they started out with hundreds of petabytes or exabytes. So that's a big compression ratio, right? It's 10 to the 18, big. And it's also $9 billion per byte. So we're spending a lot of money there. But the point here is that they reduce the data. That's just always what we're taught in astronomy, right? You start out with a lot of raw data and you reduce it to a data set which is very rich, smaller, and one's much easier to work with. So consulting, you can be a data scientist and work at a company where you might do the same kind of thing for 5 years, get really used to the data. When you're a consultant, it's different, right? So the good parts about it is you're always learning something new. You never just kind of feel like you know it all because you're always going on to a different client every few months. You're exposed to a large range of people. If you're at Thoughtworks, you're on a different team all the time. You get mixed up. So you meet over a few years. I probably met 100 people at Thoughtworks, and of course you meet people on the client side as well. And the thing I love about it too is how you get to see how everything works on the inside, right? So you move to many different companies and you see how things actually work. And sometimes it's scary, but sometimes you have the ability to kind of change those things and make them better. And you get to see the world, which is a good way of saying you have to travel all the time. And I say low career risk, but it's still fun. But I mean, two things. One thing is just that if you're in a startup, you're putting your own money in it. You're not making a lot of cash, but you're getting stock options and that kind of thing. It's still kind of a high risk, right? If that goes poorly, it didn't work out so well for you. It's a stable salary and it's just fun, and it's also kind of low career risk, I always say, because you have to get fired twice, right? Your client has to fire you, and then your company has to fire you. So you get a lot of safety there. So the bad, the clients choose you. You don't choose them. That can mean, at Thoughtworks, everyone's great. We love everybody here. When you're on the client side, you get what you get. And they often have problems, which is why they're calling you to begin with. And a lot of those problems are people problems, not people problems. And if you're just a math guy and you go in there and you think it's all about math, well, you realize you have to convince people that you're right. It's not just math anymore, right? So travel can be extreme, right? This is the see the world part. At Thoughtworks, we travel all the time, so not all the time, but quite a bit. Your great ideas will really be credited to you, right? So if you have a great idea and you're at a startup, you become famous. Your great idea becomes famous, right? If you're a consultant, and nobody cares about it, but maybe your boss, right? They say good job, but that's it. You don't get rich off it. The challenges in data science consulting. Again, like I said before, the businesses don't understand the terminology. You spend a lot of time teaching just the terminology and what you're doing and trying to explain that it's not magic, right? There's a pattern we see. The visionary CEO sends you in to completely change their company and make it a data-driven place, and it's not ready for that. The people that you actually work with are not so visionary, and they're more the kind of keep the lights on kind of people, right? But you don't always get that. It's a mix. The problems can be vague. Sometimes this is related to the one above too. If they tell you to come in and look for trends and kind of things like that, that can be okay. We try to keep those kind of projects short term. We'll do a kind of a 3-week project and look for trends and try to find things in the data. But you don't want to spend a year doing that because you'd be running all kinds of random directions and not producing value for them. So communication with the business stakeholders takes a lot of time. Like I said, it's a lot of teaching, a lot of explaining. I'd say you might spend about almost 30% of your time doing that. Right. So, and we're still working on our model. We're getting better, we think, all the time. It's more than just Agile, though. So we learned a lot in software, how to do Agile and how to make projects successful. In data science, there's new tricks you have to put in there, right? You have to learn. Partly because it's like, for example, with if you're testing code in a normal environment, you have your unit tests and you can do that kind of thing. A lot of the time in data science, what you're doing is kind of throwaway work, right? You're doing work to learn something so you can figure out what to work on next. And so you're not really testing it the same way. Some of the other things is you can't test things when they depend on the data, right? I mean, you can't test every kind of form of data that will come your way because you don't know what the data will look like. So there's some things that are fundamentally different. Some of the red flags to avoid when they say, build us a platform for analytics where you can become a data-driven company or something like that. That's first of all, it's a non sequitur that if you have that platform, you'll become that, right? But the other thing is, what's a platform and what's the purpose of it really? That can be kind of too vague, too general. Wanting to predict the unpredictable, right? Sometimes the information is not there, and no amount of modeling is going to bring it out, right? So one problem about this is, you don't know how long the project is going to last, right? You go in there, we'll look for something. If we don't see it, maybe we have nothing to do. Attempting to use machine learning on noisy data. So machine learning is not magic, right? If there's too much noise in the data, it's not going to do any better than a linear model or something, the simplest thing possible, right? So a lot of the time, the data is just very noisy. There's not a lot of trends in the data, and it's overkill to use it. When the incentives and opinions are all over the map, this is just a consulting problem in general. When you come in and they ask you to solve a problem, but then when you get there, the other people that you work with there don't actually want that problem solved. They want something else solved. So that can be complicated. Sometimes you'll find that people are convinced the problem's been solved 20 years ago. We have a segmentation model for that. We do it in SAS. And again, sometimes that's fine. Sometimes it works just fine. Sometimes there are more advanced methods that you can use that come out of the last 10 years or whatever you can apply. So, all right. So keep offering up the bold ideas. This is my Adam Sandler. I like this album. One of my heroes, Adam Sandler. They're all gonna laugh at you. It's called, and I always feel like my best ideas get laughed at first. So if they're laughing at you, that's good. I tell my wife all the time, "Oh, I thought of that idea 4 years ago. Remember I told you?" And you said it was stupid. And now there's a company doing it. And, for example, the other day I heard there's a company now. It's like a dating site for if you're at a bar and you want to date people in the bar, right? It's like a localized dating site. I had that idea 3 years ago. Everybody laughed. Anyways, just make sure everyone's laughing at your ideas. Let's see. Focus on the productivity for the customer, right? Like, they may have problems for you to work on. If you find better problems, you should really, bring it up and try to get yourself working on their most challenging, most important problems. Keep up on the cutting edge in the literature. There's new stuff coming out all the time, so it's not just the information you can find in books. New algorithms will come out a month or two ago that are much better than the ones now. So keep following that. And I guess that's it. Any questions?
You mentioned at the very beginning of the first case study, so you spent 3 weeks determining something. So do you usually go out and actually build something? Or you see where I'm going, okay, so you get some insights, now you can spend 3 months or 6 months actually building something, which probably they couldn't do even if you give them specs or whatever. Yeah. Right.
So, see, I think it's very important to build something quickly. And I think part of the reason is that the client often, they don't know what it's going to look like, and they don't know if it's going to work. And again, it's different than software, where if you're building a website, they know what a website is, and they know you can build a website, right? They don't know if you can predict the future, right, from their data. So the faster you can show them that, the better, right? You really have to kind of produce prototypes as fast as possible and show them some progress.
If you do actually succeed, let's say you think you figured something out fine, so you create that 80% on your laptop, great. So like, I mean, now what? You can give that to them and they're gonna dump this Oracle and all these temp workers and whatever.
Yeah.
But like I said, that's great, but you know.
Yeah, so that's one of the big advantages we have at Thoughtworks, right? We're a software development company.
Okay.
Right? There's, you know, a lot of consultants will be in small groups, and they'll create something cool on their laptop, and then putting it into production, you know, at the enterprise level, it's not going to work, right? So I think that's one of the advantages of our group. We're embedded in Thoughtworks, exactly with developers, you know, can deliver big projects. So if we need to port something over to, you know, to run in Hadoop or in Java or something like that, we can do that. We can put something like Python can be, you know, put into production too if you know, refactor a bit, improve it.
So how many times do you just basically literally fail? Like you go there, they're like, "Oh, can you do this for us? It sounds great," and like give us 2 weeks, a month, and you're like, "It's not gonna happen."
Yeah. Well, there's fail in the sense of that you go in there, you can't do anything for them at all, and then there's things where you go in there, they ask you to try something, you try it, and you find it doesn't work. You tell them that, you get a new problem. So there's a mix of that. I'd say most of the things we go into, we were successful at finding some way to produce value for them after a while. Yeah.
Seems like it would be very hard to go to a company that you've not gone back and forth with already, and to have something productive so quickly. I mean, the language barrier, I've done tons of these little projects like that, and sometimes it takes 6 months for the IT and the business unit to sync, and you're not in stride until 2 years later, really.
Sometimes that's the case. Sometimes you can avoid that by focusing on very specific things, right? They have an algorithm which does something that you can abstract out quickly and say, okay, I can find a better way of doing that. If it's a problem they've never tried to solve before, it can be like that, right? You have to look. You have a lot of try a lot of different things, and there's a lot of kind of backtracking and that sort of thing.
I mean, especially when they're not. I mean, they're business unit people, and their problem that they know is very complex, but they can't explain it. So, and it's a lot of times, have you encountered situations where one single person or 3 people know just a fraction of their problem, and you need to milk it from 30 people? I mean,
that can partly be what takes a lot of time. But you know, again, we're not going in there to, you know, start their business from scratch again, right? It's usually fairly specific things we try to focus on.
But David, we also break the problem up into small pieces too.
Yeah.
So one of the things is trying to say, you know, if somebody comes in and says, "Hey, I want a complex model to predict which location is going to be the next hotspot for hotels." Project we done a couple of years ago, and we started with some basic questions about, well, what makes. Let's talk about performance and just start building up so that you get, if you take it in small pieces, they're simpler questions to answer. I got a question for you, David. So, you talk about PhDs, not data scientists. Can a guy like me become a data scientist, or am I just helpless?
John, you started the group. You were the beginning of it all. You were the inspiration for us all. Yep.
There's a way to slide past that question. So really, for people who don't have a PhD background, don't have that statistics, do you think that people can make that jump?
Yes, but I mean, I think it's tricky, right? So I think the hardest part is learning all the math, and I feel like you don't learn math unless you're in school and you're forced to do problem sets for 4 years, right?
Wikipedia.
Yeah, but you know, you have to have the willpower to actually go learn that, right? And
you left that out of the presentation.
Yeah, Wikipedia. No, I mean, there's tons of information there, but you know, you have to have, I don't know, you have to get the years of working on it, right, to get through it all. I mean, that's why I think, you know, we're not going to have 100 times as many data scientists like we have now. We'll have a different kind of data science. We'll break it up in different tasks and things. You know, like you're not going to get that many people to go through grad school, do 10 years of research at low pay, and then become data scientist. It's not a natural path, right? You know, we're here by accident. Because we couldn't find anything else to do. So,
I mean, a company like yours that is approached by a client, how often is it the case where that same client has gone through one or two other engagements and they know they have the data with an answer that they're still looking for?
Yeah, quite frequently they try to do it themselves in-house, and sometimes they're fairly successful, sometimes not. But it's usually kind of a simpler model they'll try, which makes sense to start anyway, but often it doesn't work that well. Or sometimes it's kind of like, there's the joke about the plumber. The plumber comes and he just knocks on the pipe. It says $100, and they say $100 for knocking on the pipe, and he says no, it was only $1 for that. It was $99 for knowing where to tap, right? So same kind of thing. Sometimes you'll come in and you'll just recognize a problem right away that you know why the thing is not working, and if the data's not clean, or like they're not regularizing a model is a common thing, right? There are too many variables and they're getting noise.
Thank you so much. How do you like it?
Great.
You guys know me, right? We have the moment of truth. We're going to vote for this talk. And David, you're not going to see it right away because you're turning your back to them. Would you mind stand here?
Oh, I gotta turn my back to the camera?
Yes.
Okay.
No. This right beside the video recording. Guys, this is really good. This is awesome. This is okay.
Okay, close my eyes.
Can you turn it back around so they can say they can give you an honest answer? Okay. Can you look at me? It's not like you're a student. Guys, we're voting. How do you like it?
Let's get the reflection in
This is awesome. This is good. This is no. 1, 2, 3. You like it, right?
Yes.
Thank you so much. And Thoughtworks are giving $2 away. Enjoy. John, it's your pick.
No, my pick. No, I don't think we can pick.
You can raise.
Let's have a good David. How about you give us a good data scientist question? That's right. Let's see who's the first who can answer.
We're looking at the data science.
All right.
No Wikipedia's.
Name a regression model which gives you a sparse solution.
Sparse conclusion?
Sparse solution. That is sparse, a small number of parameters that come out of it.
Last question.
There you go. All right.
All right.
Can we invite
least
our
angle
data
something.
scientist team
It's,
to present next time?
Yes.
Awesome.
Yeah, so if you have thousands of variables that you're training against data, and you want a sparse solution, that is, you want most of them to be zeroed out. This is a great algorithm called that. So.
Guys, we taught this about 3 weeks ago. Oh my goodness. Are you in my group that time?
David, can you tell us a little bit about the book? What is this book?
This is Ken's book. So I mentioned it a bit.
Ken is one of Thoughtworks data scientists.
Yeah, he was the co-founder with John within Thoughtworks. So what's it about? It's really less about data science, more about Ken's experience in data warehousing and BI projects and how they failed at a rate of 50%, I think he said. And it was it's because it really never benefited from the agile leap. And part of that is because the data model is sacred, right? You can't change the data model after you created it, and that's not really true. There are ways around all those kind of problems. So he talks about kind of the ways of being agile within that kind of environment.
One more question? Even harder.
Oh, for me? Oh, I have to ask a hard question. Oh, okay. Let's see.
Anyone do Spark on Yam? Spark.
All right, so should we ask Spark questions?
Yeah.
Anyway.
Okay, do something else. I'm sorry. Otherwise, they will hate me.
You ask a question.
It's hard. Oh.
Okay,
So
let's make it a simple one. That's a little
I have
different.
a really good one.
Okay,
So,
go ahead.
how many events you have been? I want the biggest number. Get the book.
Okay. So everybody who's been to one event, raise your hand. Everybody who's been to one event. Everybody who's been to 2 events, 3 events, 4 events.
You're gonna win.
5 events. Oh, there we go.
Oh, awesome. So it's yours. No matter whatever we ask, right? And I'm so glad David mentioned Hadoop. Oh no, Python and R is 90% of the job. And I'm offering Python and R class, and my 3rd batch of R class just graduated yesterday. And they're going to do a presentation on May 1st. One of my students is going to predict the rain down to minute based on the Apple Store app called Dark Sky. So you know how many minutes you need to stay in the store before you get yourself wet. You can get the data from forecast.io and run your own R algorithm over it.
Which do you like better, R or Python?
What?
Which do you like better?
I like both.
Actually, me too. I'm kind of one of those people.
That's why I'm offering both.
I like both.
I'm the person teaching R and Hadoop class at my school. It's called NYC Data Science Academy. So if you're interested, sign up for that. Machine learning by R starting on Sunday. But my class is really hard. People cry during my class. And they also asked me for extension to submit homework. And so if you are signing up, you really have to work hard. No TV show, no concerts, no hangout. That's it. Because my class is 7 hours per day, 5 days. And after that, you're going to present to this big group, and people will vote, decide whether you can graduate or not. So it's really hard. That's why you can become a little bit closer to David, right? Work hard.
Don't get too close.
Guys, by the way, I don't have a PhD degree. I have Master of Computer Science and Master of Statistics. And my husband happened to be a PhD of mathematics, so which qualified me to become a data scientist. So either marry a PhD of those majors or get double masters. Or get one. Or take my class. Awesome. Thank you so much for coming. We have more events.
I just wanted to say thank you for everybody for coming to our event tonight. David talked a little bit about Thoughtworks in the beginning. We're really excited to support the data community and also the development community. So this facility is used for meetups almost every night of the week. Jared is our coordinator for all of our events and our social outreach. As David mentioned too, a big part of what we do is part of our social mission. So Thoughtworks is very excited to help organizations, a wide variety of organizations. We've worked with UNICEF, we've worked with GetUp, and a variety of smaller charity organizations, smaller social organizations. My point being is if you're involved in any of those types of organizations, please reach out to us, let us know. We're happy to hear what you're working on and help you out. I'm going to plug one that I'm a big fan of, DataKind, datakind.org. They're take data scientists and they help them hook up with various causes. So please, if you look at datakind.org, Jake Corway, be interested. It's an opportunity for you to learn a little bit about data science, learn a lot about data science, some very qualified people, and help out your community. And then the last thing I want to mention is, we're very happy to support other types of meetups. So if you're part of other kinds of organizations, reach out to Jared, and he can help you with that. And of course, if anybody's more interested about Thoughtworks, our organization, what we do, what types of roles we hire, that sort of thing, please feel free to grab any one of us, and we'll be happy to talk to you. One of our folks out here, Jake, will help you out if you have any further questions as well.
Two more things add. I'm an advisor for Sema Foundation, so it's similar to DataKind, and I personally mentor you. I teach you how to do D3JS, R, Python. Like we have done like homeless prediction, send social worker to help people. And I also mentor for Big Apps 2014. So if you want to compete for the platform, talk to me, I can help you. Awesome, thank you so much.